Garza.
I'm Kenya Verdisco.
I'm Jesse Dominguez.
And I'm Jocelyn Garcia.
And in this video, you'll see us build a water rocket and the data we collected throughout the process.
The rocket was built around the period of about 2 months.
The location we're doing this is at Southwest High School.
We're doing this for Physics 1 class lab.
Throughout this video, you'll see us how we built it, how we researched the project, and how we analyzed throughout all the steps.
The audio of this part of the video was corrupted, therefore I'll be narrating what each member of our group said. Mario said, so we have a project which shows all the steps to make a rocket. It has the body, the fins. We also have the procedure of how to assemble the fins. After that, we have a procedure of how to join the rocket with the fin. And so we also have to have the steps to build a nozzle for the rocket. This project is complicated because it has a parachute in its design, so we are going to have to discard this project. Kenya said, this project tells you basically what every part of the rocket works for, and it tells you the steps on how to make the rocket. So for one, we basically like the tennis ball is the point, so we are going to use the tennis ball, and that's all. What Nora said is, and we decided to use the majority of this plan. We like how it's set up the steps and makes them simple. And what we also like is the explanation of the steps to the fins, but what we were unsure about is the nose cone, which is, as Kenya said, we are going to try to use a tennis ball from her design.
So we're putting the tape, we're putting the fins in the rocket. The fins are a little flimsy because of the cardboard we're using, so we're applying various amounts of blue tape, painting tape, to make sure they stay in place. You can currently see me cutting. Okay, so here we have the almost completed rocket. We might add another 2 more fins to add more trajectory. More stability, thank you. So we have the cone here to provide air resistance against air. It's to provide air resistance when the rocket's in air. We have a tennis ball inside of here covered in tape so it could provide the center
of gravity, and we have also added the center of mass in it to add more mass so we could get an adequate trajectory.
The fins are meant in the shape to provide less air resistance. The fins are more or less stable. And yeah, no, that's fine. Oh, we also, for the fins, we created a certain pattern to be one to allow them for easy placement and tape of the fins on the rocket. Try to lower it down a little bit more. So right now we're gonna mask the fins in tape so they are equally balanced in a sense. And stronger.
Okay, so when we were torquing our rocket to find the mass of the rocket, we had to balance the ruler. So what you end up with is a mass on distance on one side and mass on distance on the other side, and they both have to be equal in order for the ruler to be balanced. And on one side, we know both the mass and distance, M1 and D1, and on the other side, we know the distance, but we don't know M2, which is the mass of the rocket. And since we know that both sides are equal, we can set up an equation over here where D1 over M1 equals D2 over M2. And when you divide D1 times M1 over D2, you get M2, which is mass of the rocket.
So here we have the photo all set up. So the rocket, here's the distance between the middle and where the rocket is, and here's the distance between the middle and the weight.
The middle is called the pivot.
The pivot point. Pivot. And so you have to get this distance. You subtract the distance right here, which is 86.5 by the 50, which is the middle of the ruler. And you get, that's how you get the distance from here to here. And you multiply it by the weight, which is 100. And here you get 50 minus 30, which is 20. And you get this times the distance times the mass divided by the distance here to get the weight of the rocket, mass of the rocket.
That part. I couldn't find it. Did you guys get videos?
Yeah, I have it on the phone.
The whole thing?
Whoa!
Oh, we got beat. Yeah, we got beat.
In order to facilitate the calculations of our rocket launch, we were aided by a program called Tracker Video Analysis. Now, before we proceed on to how we use this program to aid us, we must explain what the frames per second are. The frame rate is also known as a frame frequency, and it is the rate an imaging device displays the frames. Now, the program requires you to place a mass that you will track according to each frame in your video with respect to an X and Y axis. Once all the frames have been finished, the program automatically displays the velocity, the acceleration, and the displacement with respect to the X and Y axis in which the rocket carried out during the launch. In the following table, we can observe how the program calculated for us what the velocity, the acceleration, the magnitude of acceleration, the respective frame, and the respective time of our rocket during the launch. The following graph displays the rocket launch according to the time and the angle that was created by the rocket. A water rocket is a very efficient project to explain some of Newton's laws of motion. You can explain the first law of motion by saying that a rocket will remain in its unbalanced state until a force is exerted upon it, causing it to propel upward. You can also say that the second law of Newton is within a rocket because depending on how much air is pumped inside of a rocket, it is proportional to how much pressure is within the rocket and actually cause the air pressure to leave at a higher rate. The third law of Newton can be explained that the force of the air or the water that is contained within the bottle it is rushing out through the nozzle and actually creates a force that is equal and proportional in direction, causing the rocket to be propelled forward. During our rocket launch, we actually encountered some difficulties. We realized that 2 fins are not enough to add enough stability to a rocket during its launch. So we had to adjust and add 4 fins to our rocket. Another thing we learned is that it would be better to actually grade our water bottle with how much water is within it. So next time we could put water coloring in the water and actually track how much water is leaving the rocket during the launch.